Okay, today we're going to study counting techniques. Okay, you know, everybody knows how to do counting, right? 1, 2, 3, 4, 5, 6, 7. But that's not what we want to do today. You know, we want to solve more complicated problems. Okay, counting techniques. So first of all, we have a general rule to follow. You know, this is how do we count, right? We begin with a very simple one. Okay, if you have a pair of ordered pair of numbers, okay, so suppose you have A and B. Okay, A is going to be have how many choices? 1, 2, 3 to 5, and the B has 1, 2, 3 choices. And how many pairs of ordered pairs of numbers you can have, right? Okay, so that's the first question. We'll begin with that. So to do that, you know, you say, oh, okay, let's do the product, let's multiply them out. So the reason we just needed to do the product is because we can list them in a square. You know, it's a 1, like a 1, 1 and 2, right? 1 and 5, and then they have a 2 and 1, 2 and 2, and all the way 2 and 5, and the 3 and 1, 3 and 2, and 3 and 5. So you get a kind of rectangle, okay? A kind of rectangle, okay? So just count how many ordered pairs of numbers there. You just need just like a calculate the area, you know, similar to that. Okay, so this side have 3, this side have 5. Okay, this is called a matrix in advanced mathematics. Okay, so you just need to have okay, three rows, 5 columns, each five columns. So it's clear that you needed to do the product. Okay, so there are 3 times 5, 15 pairs. Okay, not 60 pairs. Okay, this is how do we do that, right? There's no 60 pairs. Okay, it's not a 5 factorial. Okay, you have to understand why this product of these two numbers. Okay, now we can also do the following. It's when I write down, yeah. So when I try to count, okay, something, if it's involved several steps, okay. So this is a general rule, okay. So if I count, if this procedure to count something involves several steps, if step 1 you have a K1 choices, okay, okay. Step 2 you have a K2 choices, okay, and then for example step 3 and just so on, okay, you have K3 choices. Those steps are independent. Then the number of ways, okay, to complete the counting is going to be just a product of those numbers, okay, just product of those numbers, and so on. You know, it depends on how many steps. Okay, this is the idea. Okay, just the reason it's always a product is, you know, all the steps are different, right? Each step, the option, then the choices are different. The first example, when I count all those ordered pair numbers, okay, I just divide them into 3 steps. Step 1, I count those pair of the numbers. The first component is just one. Okay, so then you can see that, okay, it's 5 choices, right? That's independent. But then the 3, now this is not, this is yeah, this is yeah, let me do this problem again. Okay, so how do we write down all the how do we write down all those pairs of numbers? Okay, questions are how many pairs of ordered okay, let me double check. Okay, how many ordered pairs of numbers? Okay, so the way we do is you the first place, okay, you write down a pair of numbers, right? So you have A and B, right? So step 1, you write down A. Okay, write down A, and how many choices? Okay, so there'll be 3 choices. Okay, because you have 3 numbers to choose. Step 2, you write down the second number, the first number, right? This is the first number, and this is you write down the second number. Okay, second number, there are three numbers there. Okay, now here's the 5 numbers. You have 5 choices, right? 1, 2, 3, 4, 5. Okay, so then there's how many numbers there? How many pairs? Then 3 times 5. Okay, the number of pairs is going to be 3 times 5. Okay, yeah, you can count the number of pairs in this way. You count the first you count the first number, right? It's a three numbers. So total you get, yeah, we don't count, how many pairs of numbers you can get, right? It's 3 times 5. It's always product. This is to divide you try to divide it into 3, divide it into several steps. In each step, you count the number of the options. Okay. So now take a look at the next problem, and then it's much clearer. But next problem is the following. Okay, I'm going to have 3 letters. Okay, those 3 letters questions how many combinations? How many combinations are we called permutations? How many permutations there? Okay, so so that means I'm going to write down the 3 letters. Okay, so step by step, right? I'm going to write down. You can list all of them, but sometimes you miss some. Okay, I'm not going to try to do that. Maybe if you have more than 5 letters, then you have more trouble. So what they do is to write down a permutation, a combination of the 3 letters. You put the 3 boxes here. Okay, that's a step 1, step 2, step 3. When you write down 3 letters, it takes several steps, right? It's not by human being, you have to do one by one, right? So step 1, you write down 1 letter, and you have how many letters there? 3 letters there. So there are 3 choices. Number of choices, 3. So we don't know which letter you're going to pick up from here, right? 3 choices. Then 2 letters left. For this step 2, you write down the second letter. Then only 2 letters left, so there'll be 2 choices. Then only 1 letter is left. There's no choice, just one, just copy to it. So in each step, the numbers of the choices are different. Okay, and the total number of permutation of a total number of combinations okay, is going to be just 3 times 2 times 1, which is 6. Okay. Okay. So you can write down all of them, like here, 3 steps, A, B, and C, right? 3 choices. So for each, in the case A, right, you have a A and the B, right? And A and the C. That's the second step, right? But the third step, that's, then here's the B and the A, B and the C. Then C and the A, C and the B. The third step is there's no choice, right? The third step is just only one, So A, B, C, A, C, B, B, A, B, A, C, B, C, A, right? Yeah. Okay. And here C, A, C, A, B, C, A, wait a minute, C, B, C, B, A. Okay. So that's why you get 6 combinations of the 3 letters. Okay. All right. Now you have more letters. Okay. So you probably cannot write down all of them because just too many. Okay. What I'm going to do is select 3 letters from this group of letters, A, B, C, D, E, F, okay, and put them in a row. Okay, without repeating. Okay, this is so that means 3 different letters. I should have said 3 different letters. Okay, question is how many words you're going to get. Okay. Now you cannot write all of them. It's just too many, honestly. So what they do is you use the same idea. So step 1, step 2, step 3. That's 3 steps. You write down the 3 letters. Okay, select. Okay, then you have this is a number of the choices, right? We usually say number of the choices. Number of choices. Yeah. Okay. Number of choices. All right. How many letters total? If you, in the first step, right? You're going to select 1 letter, but you pick up 1 letter from this group of 6. So there'll be 6 choices. Okay. Right? Then 1 letter is gone. 5 letters left. Second step, you only have 5 choices. Then third step, you only have 4 choices because 2 letters already gone, only 4 letters left. So this is a total, so the number of the words you're going to get is going to be the product of those numbers. Okay, I don't know how did you get to 480 or 60. Okay, this is what we get. Okay, and it's 120. Right, so there'll be 120. I cannot list all of them because just too many. Okay, so you have to learn how to do the counting. Yeah, instead, if you want to list all of them, it's impossible, just too many. Yeah, 6 times 5 yeah, okay, 6 times 5 is 30. 30 times 4 is 120, right? Good. Right, and our next problem is how many 3-digit integers are there? Okay, there are two different ways to solve this problem. I want to use the method we just learned. Okay. I'll give you a half minute to think about. Okay. Awesome. You don't know how many? Depends how they calculate. First of all, let's do the usual way to count, right? 3-digit numbers begin with 100 because 99 is 2-digit number, all the way to 999, right? So how do you count them? Well, before that, there's 1 all the way to 99, right? So there's a number of 3-digit integers is going to be 999 minus 99. Okay, cannot minus 100. If minus 100, it's wrong, right? Minus the number before 100. Okay. So this is going to be 900. So there are 900 3-digit integers there. That is the way we count them directly right now. Okay. But I'm trying to learn a new method here. Talk about new method, right? And to count them. The second method. That's what we want to do. Okay. You have a digits, right? 0, 1, 2, all the way to 9. So when you write down a 3-digit number, right? When you write down 3-digit number, how do you do that? Okay. The first step, okay, step 1, you write down the first digit, right? This is called the 100th digit, right? 100th digit. How many digits you can choose? You can only choose 9. You cannot write a 0, okay? So there will be the number of choices. It'll be 9. Then second step, you have to write down another digit because here is different from the previous problem. The digits can be used repeatedly, okay? Because those are not just like real objects. Those just numbers, abstract numbers, okay? So you can choose any of these 10. You have 0. The second 10th digit can be 0, so there'll be 10 choices. You can repeatedly using those digits, okay? That's the difference between this problem and the previous problem. Then the third step, you still have 10 choices. So there'll be 10. Okay, there'll be 10. Okay. So now the total number of 3-digit integers, okay, is going to be 9 times 10 times 10, which is going to be also 900. Okay. Okay, 900. Okay, so we use as a traditional method to count them, it's 900. Now we have, another more better method. Okay. So where's everybody's And let me check. Okay, it's still there. All right, so let's do the next problem. So the next problem is slightly changed, okay? Because the question is how many 3-digit even numbers? Okay. Yeah, how many 3-digit even numbers? Okay, any idea? All right, most of students get 450, that's correct. So still the same idea, step 1, step 2, step 3. And you have how many digits that you can choose? It's 10 choices. So the first step, right? You have 9 choices, right? Second step, you have 10 choices. But the third step, okay, you only can pick up even numbers, which is 5, okay, which is 5. So the answer will be the number of, okay, 3-digit even numbers is going to be 9 times 10 times 5, 450, okay, 450. Okay, our next problem is still 3-digit number, okay? We want to count 3-digit integers with distinct digits. This means we do not consider like 144. This is not a 3-digit integer with distinct digits, okay? Yeah, can you try this? Distinct means different, okay? They're different digits. So Angel got answer. Anyone has a different answer? Or? All right. Okay, we got 3 different answers now. So this is not an easy problem, son. Yeah, distinct means all the digits should be different. That means 144 should not be counted as a 3-digit integers with distinct digits. The digits are different. They're not same. Cannot be identical. Okay. So how do you write down a 3-digit integer with distinct digits? Okay, this is a number of choices. Okay, the first step, you have those many digits choose. The first one It's free, right? You have 10 choices, so the 10 choices, no problem. Now you don't have 10, 9 choices. Why 0 cannot be, right? It's 9 choices. Okay, 9 choices. Okay, the second one, right? Second one, how do you do that? Do you have 10 choices? No. Why? Because you have to choose the one which is different from the one already chosen. So if you already select one, then you cannot use one, but you still can use 0, right? So that's total 10 digits there. You can only use 9 of them because one is already chosen. Okay, so it's 9. Okay. Then the third one, there's the units digit. How many choices do you have? Well, you already select 1 and 2. See, 2 digits are selected. You cannot use them. So there will be only 8 choices. Okay. So total, the number of 3-digit integers was distinct digits is going to be the product of those numbers. Okay, so the answer will be 648. Okay, got it? So this idea involves 3 steps. Each step you write down the number, digit, and you have to see how many choices left for you. Okay, step by step. There's some less choices, right? Getting small, but the first one is 9. You cannot put 0 there. Okay. All right, so our next problem is how many still, okay, that's too many, still, how many 3-digit integers are same, okay? And divisible by 5. Okay. Divisible by 5. So let's see. Can you work out this? All right, so I hope you, well, I still get so many different answers, unfortunately. Okay, Edward gave me 162. Awesome gave me 179. Okay, Sophia Shen gave me 180. Okay, what else? So let's do this, okay? So step by step, right? Now, the key point is a number is divisible by, yeah, this is the whole point, okay? So this is a difficult, honestly, yeah, okay. So a number, let me see, here's a fact, okay? A number is divisible by 5 if and only if the units digit is going to be 0 or 5, right? Do you agree? So I think with this time we have to do the following, okay? We have to divide them into two groups. Okay, either in the first group or the second group, then add them together. So you count those 3-digit integers, the last digit, the unit digit 0, and you also count those 3-digit integers, the unit digit is 5. Okay, let's count the first one. Now the first one, okay, so the 0 is already used, right? You have how many digits there? You have a 0, 1, all the way to 9. So 0 is already used. So you only have 9 choices for the 100th digit. Okay, you only have 9 choices for 100th digit. Okay, right? That's one. And then 2 digits already used. So for the 10th digit, you have 8 choices. Okay. Okay. Right? Do you agree? Yeah. So 0 is already used. That's from 1 to 9. You have 9 choices, right? Right? Yeah. Okay. Now, for the second pattern, right? Second pattern, 5 is already used. The point is the first digit, okay? The first digit cannot be 0. Clear, right? So already 5 use it, 0 cannot be used. How many choices for you to choose? 8, right? Then the 10th digit can be arbitrary, right? But cannot be, hold on. Wait a minute. Yeah, I did it wrong. So I have to add a sentence called this with distinct digits. Be careful about this, okay? So 3-digit integers, if you do not assume the digits are distinct, okay, then you do have more choices on the first one. Yeah, I was thinking about something. I was thinking. So the digits can be used over again, okay? Okay, so yeah, unless, sometimes I will put additional comment, okay, say with distinct digits. Yeah, that will be different, okay? So the digits can be used over again. But, okay, so the first one, yeah, the first one, you see the 100 digits cannot be cleared, cannot be 0. Then the second digit, you have 10 choices, okay, not 9, okay? Second digits can have 10 choices, okay? Right, 10 choices. Okay. Okay. The second digit have 10 choices. Okay. The reason is the digits can be repeated. The digits can be repeated. Now, the reason I want to divide into 2 groups is because I want to modify this formula. Okay. Then, and the same story here. The 100 digits, there are only 9 choices. Then the second one is 10. Okay. Okay, because you can use any digit in the middle. So the answer is here's 9 times 10 is 90. Here's 9 times 10 is 90. So the answer is 90 plus 90 is 180. Okay. Now, if I modify the problem a little bit, that's okay, difficult. Okay, how many 3-digit integers? Okay, first of all, was distinct digits and divisible by 5. Okay, and in this case, the problem is a little bit more complicated. So let me give you 2 different patterns. Okay, so that's the reason 5. Okay. Okay. You have digits 0, 1, 2 all the way to 9, right? So now it's a different story. Okay, distinct is very important. Okay, so you have 9 choices for the first one because you cannot use 0. Okay, anyway, you cannot use 0 because 0 is already used, right? It's okay. Now for the second one, 10th digit, because all the digits must be different. All the digits must be different. So only the 2 digits are used, right? So then you only have 8 choices. That's what I'm saying, okay? Then for the second pattern, 5 is used, but you cannot use 0. So that's why you only have 8 choices, okay? But for the 10th digit, you already used 2 digits, so still 8, okay? Still 8. So 8 digits you can choose. So the answer is 9 times 8 plus 8 times 8, okay? Okay, so that is 72, 84. So it's going to be 6, 136. Okay, 136. Yeah, this is a little bit difficult. Yeah. All right, so let's try a different problem. Okay. Now this time we have a lock. The lock has 3 dials with the digits 0, 2, 4, 6, 8 on each. Okay, so you have a lock. Okay, so this is a lock. It's a 3-digit. Okay, 3 dials. So each of them have like a numbers, rotating. Right. This is a lock. With the digits 0, 2, 4, 6, and 8 on each. Okay, how many different settings are possible if all 3 digits have to be different? If all 3 digits have to be different. Okay, so that means you cannot have 2 identical digits. Yeah, for example, 0, 4, 2, that's okay, right? You get this number. Okay, this is okay, but 0, 0, 2 is not okay. It's not. Right. Now you get ideas, right? So you have 3 steps, right? First step, you set the first one. You have 5 choices, right? Right. Then the second one, yeah, this is different from the 3-digit integers. Then the 3-digit integers, the first one cannot be 0, but here, first one can be 0, so it's 5 choices. The second one, you only have 4 choices because you cannot use the one already used. Then the third one, you only have 3 choices because you cannot use those 2 you already used. So the answer is 5 times 4 times 3, which is going to be 60. So there are 60 different settings you can choose. Okay. Okay. All right, so we have our next question is, I'm going to write down write down three let. Let's see. Okay, I'm going to do this license now. Okay, so license planes. Okay, so here's a combination. Okay, so license planes are issued that contains 4 digits followed by here's a rule. Okay, 4 digits followed by 2 letters. Right, and also the letter O and B cannot be used. O and I cannot be used. Okay, how many license planes are possible? Okay. So a typical license plate is going to be like a 2000, right? 2000 AB, for example. Okay. So letter O and I cannot be used. The number of letters, how many letters there, right? Total 26 letters. How many letters? 26 letters, right? From A to B all the way X, Y, Z, right? Yeah, A, B, C, D, E, F, all the way X, Y, Z, right? All right, yes. So for each, let's, how many steps here? 5, okay? So the first 4 steps, each time you have, because 0 can be used, right? Each time you have 10 choices. But for the letters, you can only use 24 letters. Okay. So the answer is, it's a really big number, 10 to the 4th power, 24 squared. Okay. If you multiply them out, it will be 24 squared is 576. You just add the 4 zeros at the end. Right. 4 zeros at the end. Okay. Okay. Another question is simple. Okay. In how many ways can 9 people sit in a row, be seated. Okay. Well, that's just mod, right? That's easy, right? Yeah, 9 factorial. Okay, so the way we do get a 9 factorial is as follows. And you have 9 people here, right? 9 people. So you put 9 chairs. Okay, so the first chair you have 9 choices. Then you select one and put it here. Then only 8 left. Then you select 8. Then you have 7 left for the third seat. 7, 6, like a 5, 4, 3, 2, and the last one has only 1. Okay, so let me say 5, right? 6, 7, 8, 9. Okay, so the answer is 9 times 8 times 7 times 6, 4, 5, 3, 2, 1, which is 9 factorial. It's a pretty large number. Okay, it's a pretty large number. Okay. Now, I modify the problem. We have 2 Americans, okay, 4 Chinese, okay, and also 3 Spanish. Okay, total we have 9 people, right? 9 people, yeah. 9 people. Okay. Now this time I do it differently. Okay. The question, still the same question. How many ways can these 9 people be seated? Okay. But there is a restriction in a row so that the people of the same nationality will sit together. Okay. So that those of same nationality sit together. Okay, so this is a different. Okay, how do you, if you're the person, how do you make arrangement? Then how to cut all the possibility? Now it's not, cannot be 3 factorial, because when you permitted to Chinese switch the seats, you get different arrangements, right? Yeah, this is difficult. I'll tell you, there will be more than 1,000 ways to do an arrangement. The problem before that, right? It's a huge number, again. Okay, so the way we design, let me give you a hint. So you have to put them in a group, right? So this is called step 1. Choose one group. C means Chinese, group of Chinese. A means group of American, Spanish. Okay. So first you have to do step 1, right? Arrange those groups. Okay. Yeah, arrange those groups. Step 1, you arrange the Chinese first, maybe American second, Spanish third, or Spanish first, Chinese second, So there'll be 3 factorial ways to put those 3 groups there. step 2. And you just needed to make arrangements for the Chinese. Okay. For the Chinese, there are 4 Chinese there. You can permutate those Chinese. So before factorial. And the step 3, and for Americans, the group of Americans, that's 2 factorial because there are 2 Americans. They can switch the order, which is 2. Step 4, Spanish. There are 3 Spanish there. So 3 factorial many arrangements. Total, you have to go through 4 steps. Okay, step 1, you decide which group should be sit first, which group should be sit second. Total, you have 3 factorial many. Then for each group, then you go to each group, you do the permutation. That's a step 2. Step 3 for American group, right? So total, the answer is 3 factorial, step 1, 4 factorial, step 2, 2 factorial, and 3 factorial. Okay, and that is going to be 6 times 24 times 2 times 6. If you multiply out, 1,728. Okay, so you have to design the way, divide this procedure into several steps. And you count the option, numbers of choices for each step. That's a key point, okay? All right, so our next problem is, it's a little bit also different. How many words one can get by permutating the letters in the word boss, okay? So if all those letters are different, then you have 4 factorial different words, right? Suppose, yeah. So, look at the case here. BOAT. Okay, those 4 letters are different. Then if you permutate those 4 letters, it's the same as like you select those 4 letters, put in a row, right? And then you have a 4 factorial many choices, four choices, 3 choices. For the third letter, you have 2 choices and 1 choice. So the total, if we work on this, then you have a 4 factorial many. Answer is 4 factorial many different words you're going to get. 4 factorial is going to be 24. You can list all of them, BOAT, BTOA, BATOB, for example, right? But for this word boss, if you interchange those 2 letters, S and S, you don't get a different words. That's a key point. Okay, how do we divide? How do we think about this problem? And maybe I can put another S here on the bottom. Okay, so what I'm going to do is step 1. I just assume those 2 letters are different. Okay, S1, S2. So then you got how many? You still get 24 letters, right? 24 words. But I only consider those in the same order, S1, S2, or S1, BO, S2, and I divide them into 2 groups like that, okay? Then here, I only consider those S2 is first. Total, you are going to have 4 factorial, which is 24, right? Many such words there. But you know that those two are identical if you remove the letters, right? If you remove the letters. So actually you have 2 groups here. Those two are the same, right? So the count, the words, those are identical actually after you remove the sub-indexes, okay? They're identical. So that's why the number of words you are going to get is going to be 4 factorial divided by 2, okay? So you only count the column on the left because the column on the right are identical with the column of the left if you remove the numbers 1 and 2. Okay, so that'll be 12. Okay. Okay. However, if you have if I increase the numbers, okay, a number of words one can get by permutating the letters in the word BOSSS. Okay. Now they have 3 letters are different. Okay. So what I'm going to do is I label them 3 letters. Okay. So you still get how many? 1, 2, 3, 4, 5. So you, if they are different, you have a 5 factorial many different words you're going to get. But I'm going to put them in a 6, because when I permutated 1, 2, 3, I have a 3 factorial many choices. So I get, 3 factorial, which is 6. I want to get 6 groups, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So this group is 1, 2, 3. This group is 1, 3, 2. This group is 2, 3, 1. 2, 2, 1, 3. Okay, then 2, 3, 1, and 3, 1, 2, 3, 2, 2, 1. Now, what does that mean? That means I only consider those words B, O, S1, S2, S3. I can have S1 first, but the order is still in the same order, 1, 2, 3, okay? And then here's a B, O, S1, S3, S2. And I can have a B, S1, O, S3, S2. You see? So you know what I'm talking about, right? So that means I divide 5 factorial many. 5 factorial is going to be, if you multiply them out, right? 5 factorial is 24 times 5, right? Yeah. Okay. I divided them into 6 groups. Okay. Where's the 6 from? 6 is 3 factorial. Okay. So, but all those all those groups, you see, this 2, if you remove the indexes, they're all the same. Okay, they're same. You don't see the difference. All you have to do is just count the number of words in the first column. Okay, so the number of the words in the first column is going to be 5 factorial divided by 3 factorial. Okay, just divide by 3 factorial. Now, we understand why I have to divide by 3 factorial, because if you have 3 letters are identical, the idea is that total, if you label them S1, S2, S3, you have a total, you have 5 different letters. Okay, then distribute in 6 groups, 6 columns. Okay, so if you remove the remove the numbers, and you find out those 6 different columns, they have the same words. So that's why you just need to count the first column, the words in the first column. Okay, you just total number divided by 3 factorial. Okay, that gives you divide the number of the groups, right? So that gives you the number of the words in the first column. Okay, so this is how do we count if they are identical letters. Okay, so there are some problems will be on the maybe in the homework. Yeah, please pay attention. Okay. Okay, so let's stop here.